Good morning, everyone, and thank you for being here with us at the 2016 Esri Singapore User Conference. Happy to announce that there's an exciting lineup of new capabilities and solutions for you that will help you to enhance and expand on the work that we're all doing as part of the geospatial community here in Singapore. I'm sure you're all looking forward to it as much as I am. So let's get started with a quick peek at what exactly is this vision of a smart GIS.
The future of smart drives organizational performance, boosts productivity, offers faster response times, and ensures sustainable communities around the world. The future of smart begins with GIS. Today's competitive advantage revolves around data. Field data, sensor data, and enterprise data all flow into your organization at volume and speed unimagined before now. GIS turns big data into insight at the speed of business. It transforms data quickly, finding patterns even before you begin your analysis. Unique contextual maps layer and integrate data based on space and time attributes, creating an interactive digital view of your data so you can explore it, enrich it, and interpret the results. The power of advanced analytics creates a new kind of awareness that identifies opportunities and threats in your operations, putting the geography of your organization to work. GIS turns your data into insightful real-time dashboards that enable you to speed decision-making and react to changes as they happen. Prescriptive analytics validate those decisions and offer sophisticated techniques that process data at speed and scale. The power of GIS allows you to share insights and maps throughout your ecosystem, completing the circuit of information. Now, anyone in your organization can understand and act on the insights you've created. The future of smart is here, now.
Well, hope you enjoyed the video. GIS is getting smarter, so today advances in technology and smart nation initiatives are changing the way in which organizations are operating, and GIS and location technology is increasingly playing a bigger role in driving up this innovation. Be it the Internet of Things or smart mapping in 3D, the ArcGIS platform has evolved to seamlessly support this journey into the future. In fact, when we were at the recent World City Summit at Suntec a few months ago, one of my colleagues and a very dear friend at that made a very interesting comment. So this year, while she walked the floor, every technology vendor had something new in their bag of tricks. They all had a map. So the fact that some of those maps were smarter than the others, but this fact that they all had maps to showcase IoT and other smart capabilities clearly shows the degree of spatial awareness there is today than ever before. So what exactly is smart mapping? I'd like to agree with Thomas and Xiaoyang that in this new era, a smart GIS is about being able to process information in real time, connecting everyone, and being able to apply advanced analytic techniques in both space and time to give us insights to what is happening on the ground, as well as to predict what the future may hold, depending on the decisions that we make today. This is about making your GIS platform implemented using a Web Gis pattern lighter, smarter, and faster. Today, we're all familiar with the notion of breaking down barriers and getting individuals in different parts of our organization to share and collaborate around non-sensitive information that can benefit the rest of the people in the organization or the community. In fact, very recently, I met the CIO for one of the waste management organizations in Singapore. So their office was in this really extreme end of Singapore, beyond civilization, single-story building, cars still packed around the office, no multi-story car parks. And when they wanted to ingest their location data into our real-time dashboards, I was frankly a bit skeptical about what form that data would be in. But I was mistaken. So while their biggest challenge was something that we couldn't address, which is to entice more people to actually engage in the garbage collection industry, what they were doing was basically is to maximize on technology, specifically location technology, to make their operations as lean as possible. So guess what? So the CIO proudly told me that all his location was updated in as real time as possible and shared as web services so that his CRM systems or his incident management systems could now have the most updated information to work off. And their vision was to be able to leverage on location technology so that they could share this information in the most updated manner back to the stakeholders. So this is quite exciting. How does the GIS platform make all this possible? The answer to this is because GIS is a complete web mapping platform today. It means that ArcGIS is able to leverage on web services as a system for managing and applying geographic information. This entire bundle of technology or system of technology is deployable on premises, on the cloud, or on a hybrid combination of these two. And it's fed by services. And these services can now share your GIS capabilities across any devices, be it browsers, smartphones, or desktops where they were originally created. And as Thomas mentioned earlier, this platform enables multiple types of systems with a common platform, systems of record keeping, transaction updates, systems of exploring the data, creating understanding and insights as an objective. So the beautiful part of this is that all this is in one platform and brought together, pulsing in real time. In a sense, it is a platform for understanding and integrating the entire organization. So not only that, the platform that we have today is also evolving rapidly. And this is, like Thomas said, a non-disruptive evolution. We're not talking about a replacement technology, but about enhancing what you already have. So what you're seeing is that instead of traditionally sharing GIS is just static maps and reports, now you're talking about organizations sharing it as capabilities. So we are moving away from standalone client-server desktops to web services and apps. We are moving from static data models to intelligent web maps and layers. We are moving from single servers to distributed parallel computing environments, from traditional proprietary data systems to open data and shared services, 2D to 3D, and then of course moving from heavy, complicated map creations or digital cartography to very simple, lightweight, smart mapping. So in summary, we are moving from a static world to a smarter, connected world that can integrate information in real time, connecting everyone, and applying advanced analytics and visualizations for better understanding and sense making. At this juncture, I'd like to invite Felicia on stage to help us to take a look at some of the new capabilities available in the ArcGIS platform since the early part of this year that makes this all possible. So over to Felicia to showcase some of our cool real-time capabilities.
Okay, thank you, Anjusha. Okay, so now let's put into action some of which Anjusha has been talking about. We are going to focus on real-time GIS with live streaming data. I will then move on to show you some of the ways in which you can apply continuous analytics to the incoming streaming data. Lastly, I will move on to perform some advanced analytics on desktop GIS. So what's really real-time GIS? We can describe it as a continuous stream of events flowing from a data feed or a sensor. Have you ever wondered where all the taxis are when you needed it? Here, we have the vacant taxis availability live feed, which is hitting us at probably 6,000 events per minute. This feed was streamed from LTA, mytransport.sg, via API call. We have been streaming at these feeds for a few days, which mine nearly millions of features, and it might hit billions if I stream for a month or so. So where can I store this huge amount of data while keeping the geospatial information of these feeds? Today, we have the capability to store and archive this huge quantity of data and withstand high velocity output across multiple nodes. It also leverages big data analysis technique to query and analyze bigger quantity of data that we've ever been able to before. Through a web browser here, as you see, this is the ArcGIS Online, we are able to visualize the data that is captured by the big data store. With the huge amount of data feeds, it will be unmanageable and unsustainable to try and display them all at once on the map. Aggregation comes into place and closes them into grids to give a better view and a more manageable, understandable view of the data. If you keep an eye in the numbers in the grid, you'll see them updating live every minute. As I zoom in, the feeds is reanalyzed, the grid dynamically resized, and give an updated summary of the data based in this extent. To do this through traditional methods would have taken a lot longer. I still have the ability to click on the grids to query individual features beneath it. Okay, let me zoom in. Okay. So here I'm also streaming the traffic incident currently happening on the road every 5 minutes, such as accident, roadworks, heavy traffic. Okay, let me zoom. Okay. Now, while it's easy to stream data feed and then display them in real time, the next thing you might want to do is to perform continuous processing and analysis on the data that you are receiving. Look, I have a dashboard here which monitors the live traffic incident and the vacant taxis availability. Any organization can use this operation view to focus on aspects of the operation that matters to them. My aim here is to find out how many vacant taxi drivers are caught up within a slow-moving areas due to roadwork, accident, or slow traffic. As soon as there's an incident, a dynamic 500-meter geofence will be created to represent slow-moving areas due to traffic incidents. I will then use this to overlap with vacant taxis to find out how many potential taxis will be caught in area with traffic incident. Isn't that great if this information can be continuously analyzed and disseminated to the taxi drivers? Okay, other than analyzing on the go, we should take a deeper look at this study with advanced analytics tools available in desktop GIS, which is the ArcGIS Pro. The services that we just seen within browser can also be viewed in desktop. Okay, looks like the feed is not appearing. Okay, now have a look at this huge data set at quite a high level. We can easily create chart to explore the relationship of the unavailable taxis that are held up due to roadwork, accident, or other impedance. From the chart here, we can see that the taxis caught up in traffic congestion increases as the traffic incidence increases. Next, let's drill down further to identify consecutive hotspots to avoid that may cause traffic congestion for the taxi's driver. Okay. To automate this process with real-time streams, we have created a model for this analysis, which can be repeated. This model brings in real-time streams and processed using the emerging hotspot analysis tool. Now, let me show you the output. This analysis was used to find significance value of each cluster and their respective category. Authorities now can use this resulting data set to improve the availability and accessibility to taxis during peak hours by informing the taxi driver which area to avoid that may cause delay to your journey due to high demand areas. Finally, let's take a look at some visualization methods available within the desktop. The emerging hotspot looks quite good in 2D. Let's take a look in 3D. Now, combining with space and time, you can see that this area are having a higher density of traffic incident at the start and the end of the day, compared to this that's having a high density of traffic only at a certain time of the day. 3D isn't just for visualizing real-life features. It can also be used for showing other tabular value. Imagine this shows the population over an area or rate of crime. This visual functionality isn't limited to desktop. We can also have it within the browser. I can share it to the web app builder, which now supports 3D, and using the 3D effect widgets, we can animate the view as well. That's not all. This information can also be shared to the public in a story map Or I can quickly configure a responsive web application to make this information available through the mobile devices of the taxi's driver. As you can see, the advance in real-time, desktop GIS, and 3D have been really impressive over the years. So probably at the end of the conference, if the drivers here would like to know if there's any traffic congestion on the way home, or those that are taking taxi, feel free to catch me along the corridor to find out if there's any available taxis. Thank you.
Thank you, Felicia. So what Felicia showed us was the tip of the iceberg, but the essence of it is that there are several workflows, both big and small, that can now be smarter with an agile, configurable, and open framework that allows us to seamlessly bring in both real-time and static data, perform rapid analysis to interpret trends, and enable better decisions, and also share our findings and outcomes with the rest of the geospatial community within the areas that we operate. So that's not all. ArcGIS capabilities are advancing. I would like to go deep on just a few of this to give you an insight. Today you'll be in sessions and hear from others that will do it a lot better than me. But mapping is going through a transformation process, and this video will give us a quick snippet of how it's changing the work we do.
Start with a story idea. Sell the story to management. Think, how do I create the story? Need data. Lots of data. More data. Big data. Where do I find the data? Call each department. Collect the data. Not enough good data. Survey new data. Call the lead GIS expert. Build a crazy model. Another model. No, not that type of model. Bring in an analyst to analyze the crazy model. Don't have a good base map? Call in the cartographer. Build a base map. Not ready yet. Go back to management and ask for more budget, more time. Be told you have no time and no budget. Work nights, work weekends, take a course in GIS. Output map, put in folder, mail to client. New rules. Start with a story idea. Grab data from the cloud. Choose template base map. Add photo from your phone. Share with departments. Tweet client link to map story. Clock out early. Every map has a story. Tell yours.
I'm sure many of you in the audience would be able to relate to those kind of mapping marathons that we have once in a while. So as we just saw here, the ArcGIS platform is not just about tools and technology. It comes with rich content that you can use as a jumpstart to enable your mapping applications and analysis. It contains not just maps from Esri, but it's also complemented with millions of user contributions that are being shared and that helps you to enrich each other's work. Not only that, Esri's recent partnership with Digital Globe means that the best imagery for the planet can now be easily accessible via ArcGIS Online. In the field of mapping and visualization, we are advancing the tools that support smart mapping, smart charting like Felicia showed, and new tools for data exploration. So if you look at it from a multidimensional space, it's not just integrating 3D, but inventing new forms of cartography and 3D with space-time integration. Earlier this year, we also introduced something called multi-scale symbology and vector tiles. In Esri, vector tiles are much more than simply having it on the cloud to make interesting maps that you can personalize. In ArcGIS Pro, you can now produce your own vector tiles and implement your data in smart devices that you can then take out to the field in connected or disconnected mode. So for professional GIS mappers in production and mapping and charting, improvements are being made that support new standards that leverage on templates and cut down the time for map production from a few weeks to a few days or a few hours. Now, as well as geospatial information, governments and government bodies are increasingly reliant on statistical data to inform policy and decision making. As resources become constrained, it's increasingly important to ensure that they're used in the most efficient way possible. And geography is a medium through which statistics are interpreted, whether at a global, national, or regional or subnational level. Now, as the need for better statistics increases, so does the need for greater integration of statistics and geospatial information, resulting in what we call as the spatial statistics. But today, there are very limited tools that bring you the power of a GIS beyond just dots on the map or aggregations, and are able to combine it with statistical techniques to perform efficient data exploration that you can use to make a decision rather than just seeing a map that looks as pretty as a picture on the wall. So earlier part of this year, we introduced a new app called Insights for ArcGIS. This is an app that I think will transform understanding using data exploration or exploratory analytics. The app is very intuitive and visual, and it responds to very huge datasets as well. Next up, I'd like to invite Casey on stage to give us a quick peek of Insights for ArcGIS.
Thank you, Anjusha. So Insights is actually a new experience for exploratory and interactive spatial analysis using the concepts of map, charts, and tables. I would say in a very easy to use, fast, and intuitive manner. So I'm actually tasked on an exploratory process to find out the relationship between dengue and age. With Insights, we introduce the concept of workbooks, pages, and charts. You can drag your data and show it on the card as a table, chart, or map. As I drag along my temporal data onto a card, it immediately gives me a timeline of my data. With the interactivity, as I click along the line, I can see the symbols changing. Well, I have too many points on the map. Let me change the symbol type. Now as I click along the line, I can easily identify the spatial temporal patterns which are underlying in my data. Now let's get back to the question between the relationship of age and dengue cases. First, to do so, I'll need to understand how are the cases distributed based on boundaries. To do so, I'll need to perform a spatial aggregation. To do so, all I need to do is to drag and drop. It's as simple as overlaying a polygon. Throughout performing analysis, Insights provide you statistics. As I click on any point, I can see the data and how it compares with the mean. So from here, I can pick out the high values areas. At the back of my card, I have the overall statistics of my information, and I can actually view this information at any point of the time. So rather than just seeing traditional maps, we can actually see interactive charts, and tables. Rather than just seeing some normal pie bar charts, we can actually see a tree map, or probably even my personal favorite would be sorry. So throughout this analysis, you can actually see that all the data interacts. So throughout this visualization, interactivity is the most important. So as we see in some areas, there are more elderlies, and I see that there are actually some more significant cases. So to drill down further, I can actually create a scatter plot to visualize my data. So scatter plot allows me to explore the relationship of the number of elderlies and my dengue cases. Do the number of dengue cases increases as there are more elderly? It seems so, but if we add the statistics to it, I would say that there's actually a weak relationship. Now I have my findings. I'll need to share this information out to my colleagues. Within Insights, everything I've done is recorded. Insights created a model of my workflow. Everything I've done is actually documented. So now all I have to do is share this model of my workflow to my colleagues, or rather I could actually update my data and rerun the analysis based on new dengue clusters. Thank you.
Thank you, Casey. Wasn't that exciting? Imagine not having to switch between multiple tools, one for doing the statistical analysis and the other for geospatial. What I liked best about Casey's presentation was the last part. How many of us would have run through data analysis and exploratory techniques only to find out that if I wanted to repeat it, I forgot what I did a few months ago, or probably I have to ask the person who did it to document it down. So here you have a tool that actually records the whole process so that you can repeat it as much as you want. How many of you in the room are interested to get insights? Yes. Would you be happy to hear that it is available for free? It's for, before we jump in, it's available for free for enterprise licensed customers. So all those who are on ELAs today are going to get it as part of their entitlement. For those of you who are not on ELAs, not to worry, it is available as a premium app with Portal for ArcGIS, which I believe most of you already would be having as part of your server entitlement as well. So post the sessions, feel free to go down to the Singapore booth to try it firsthand and inquire how you can get started with it. Okay, now beyond data exploration, we're also working with other spatial analysis tools. There's a lot of them here. I'm not going to go through all of them, but I'll probably tell you the 2 new ones that have been added and that give an extra dimension to site selection and so on. So there's actually these 2 new tools, which are the locate optimum regions and the landscape corridor selection. So these 2 tools allow you to do site selection a lot better by kind of like finding out where are the optimum transportation corridors, or which are those regions that closely have similar land use patterns as well. Now, apart from that, we're also enhancing the spatial statistics dimension and having better integration with R as well. So this integration has huge implications to us, especially for those of us who are doing data analytics, because by leveraging on this bridge, ArcGIS users can now leverage on the power of R to be able to do predictive analysis and so on from within the confines of the GIS environment, and likewise, our users can also leverage on mapping capabilities. Now, on the right side of the diagram, you can actually see there's 2 big data analytic tools. These are analyzing massive volumes of data in both raster and vector domains, either from Pro or from browsers. So today we are moving this world where everybody a few years ago was talking about being able to harness big data. Today the scene is, I've already been able to kind of like store the big data using those architectures and so on. The next thing is, what do I do with all this data? I spend so much infrastructure to get things up and going. Now what am I going to do with it? Is it adding value to what I'm doing as an organization? So today in Esri, you're able to kind of like process this information in parallelized distributed computing environments to get insights from your big data in a matter of a few seconds or minutes. So shortening the time window for being able to do complicated problems, like let's say, for example, I want to actually analyze millions of commuter movement patterns for the last 1 week or maybe for the last 1 year to see how the trends in probably the housing and things have changed the way that they work. I can now do it in a matter of a few minutes or a few hours. So providing this massively parallelized processing environments will be able to help us to create new insights and solve problems that we could never think we could solve before. So next up, I'm going to invite Hui on stage to give us a quick sneak preview of geoanalytics for ArcGIS. Thanks, Hui.
Thank you, Anjusha. As Anjusha mentioned, we are moving towards a world of big data, where the Internet of Things means continuous data streams can come from anywhere, like sensors for your weather, from GPS systems, vehicular tracking, smartphone data collectors, from media streams, or among others. Visualizing all this may turn into a struggle. The issue with large data volumes is that you're just waiting for the data to draw without being able to see any particular patterns emerging. This particular data set is taken from about 1 week of historical taxi feeds, and it has about 60 million taxi records. To find possible patterns or relationships, one way is to do a simple aggregation. You'll notice that there appears to be very high activity not only in the central region, but also in Hougang, Geylang, and Kallang. But can you say that this has always been the pattern? Is there any way to find out? And how did we actually do this? New capabilities are being introduced into ArcGIS so that you can work with huge data volumes by running batch analytics across clusters of machines from within ArcGIS, and also, of course, using workflows that are already familiar to you. So what this means is that you now have access to tools that you can use to apply familiar spatial analytics to understand patterns behind your huge data volumes. You can summarize to find patterns. You can reconstruct movements of typhoons, or vehicles or goods for tracking purposes. You can also choose to calculate density distribution patterns or to find hotspots of persistent activity, among other things. Let us just take a further look. So what you see here, again, is the raw count or taxi activity aggregated into regular bins. Or, if you want, you can choose to aggregate into more knowledgeable patterns, for instance, like planning areas or housing estates. With these, you can actually begin to explore if patterns are different from what you would expect. For example, you may notice that there appears to be a higher pickup rate along this corridor. But if you remember, this corridor actually has a pretty well-developed public transport routes, be it MRT or the dense number of bus stops. This unexpected additional insight could prove useful as an impetus in considering other factors that generate or attract taxi trips. Or you could choose to further enrich your analysis by including age or income distribution factors to see if they play any part. Or you can choose to calculate density patterns to look at the distribution of the information. Here, what you can see is that the density of busy taxis at about 8 a.m. So potentially, everyone else should be able to grab taxis, right? You can use these initial patterns as a springboard for further analysis. For instance, would there be a correlation between higher pickups and the number of taxi stops? Would age or income distribution play a part in influencing preferences for transport modes? You now basically have access to millions of data, but what if you're interested in finding out more? For instance, are there any time periods during the day where longer taxi trips happen? Or, from a driver's point of view, when do I have to drive longer and actually use more petrol just to find fares? You may think that this is a job only for domain experts, but with the new ArcGIS geoanalytics course tools, you can actually start your journey in finding these patterns. With the reconstruct paths tools and others, these initial travel patterns can be actually reconstructed. So what we have done here is actually collated the 60 million historical taxi records by the taxi IDs and also by the time periods of the day. And what appears to happen is that longer trips occur during the early or late hours of the day and also during the lunch hours. But what does this mean? Does this mean that the taxis are spending a significant part of their service during these hours to actually cruise for passengers? Or are they traveling longer distances just to avoid any traffic jams? Has the introduction of information services over the years, like cab-hailing apps, made any significant impact in changing not only these patterns, but also influencing the quality and service provided? These outcomes are useful, not just for planners, but also for anyone who seeks to gain understanding from the avalanche of information that we are receiving. The above is just a preview of what's possible for you to harness the power of distributed processing on your vector big data. The geoanalytics capabilities built on workflows that are already familiar to you, letting you work with both existing GIS data and, of course, your new big data, providing you with both insights to both spatial and temporal patterns. Thank you. Back to you, Anjusha.
Thanks, Hui. Wasn't that exciting? And the best part for me is, like Hui mentioned, that we as geospatial people can now work with big data, just like how we work with any other kind of data, without having to be at the mercy of programmers or transform ourselves to be programming ninjas ourselves. So those of you who worked with big data as recent as even 6 months ago would know what I'm trying to say. So with ArcGIS's new geoanalytics capabilities, what it's really doing is it has this new way of processing spatiotemporal data into big data analytics by leveraging on distributed analytics and usage it works well with both your existing GIS data and tabular data, and this data could be residing on your ArcGIS managed systems, or it could be in your existing big data infrastructures as well. So geoanalytics will bring the power of distributed analytics to your big data and open up entirely new ways for you to mine information across both space, time, and signal. And we're looking forward to see how you apply these tools and answer the questions that you never imagined you could before. Another area that is closely associated with big data is real-time information. And here our work is about streaming in real-time information in high-velocity data streams and being able to apply continuous analytics to process it to give insights in real time. Felicia showed us how we could ingest a few thousands of signals in a matter of seconds. In this next release that's coming the end of this year, you would be able to support hundreds of thousands of signal information in real time with the ability to aggregate and apply continuous analytics to extract insights. Our work in 3D is also improving capabilities for supporting 3D across the entire platform. So we have new apps like ArcGIS Earth that are allowing free access to all your scientific and other sorts of data, connected and disconnected. So we made improvements in urban landscape visualization. There's added ability to extract buildings, for example, from LiDAR. And then there's this new support for point clouds and a 3D integrated mesh that is being adopted by the entire 3D community. Now, if you look at the lower left, you'll actually see this animation about 3D Web GIS. So what is amazing about this is that today your 3D content and analysis can be accessible on a browser without the need for any plugins. So this is exciting because it means open access to 3D or n-dimensional time from via browsers to everybody. My two colleagues, Thibault and Zara, will speak more about it later. Imagery is also an enriching and fundamental part of the ArcGIS platform. Here we are improving capabilities for better orthophoto, orthomapping, and image analytics, and also image management. You can look across these images and try to find your favorites. My favorite today is a little application that's being already released called the Drone to Map. It allows you to fly a drone, grab all the imagery, throw it on your desktop, and then a few minutes later get an ortho map and a 3D point cloud. Isn't that amazing? I've tried it myself and it's quite spectacular. So later this afternoon we have an amazing presentation from our friends at NParks. So look out for that. In the app space, GIS is opening up with the app revolution. So gone are the days where you needed to custom code every single app for your users. So the needs and situations that your users are dealing with today are changing so rapidly, it can be tough to custom develop everything. So today the Web GIS comes with this collection of ready-to-use disposable apps, both for the field, for office. Insights was an example, and you also have these community crowdsourcing applications that you can leverage on. Now, apart from all these apps, Esri has also published hundreds of open source data models and reference solutions on GitHub that are based on industry best practices that you can download, personalize, and deploy. In Singapore alone, we have several enterprise customers that got up and running in a matter of a few weeks using these best practices templates and blueprints. So some of you out there would definitely have the need to create your own apps as well. So there are 3 environments to do this in ArcGIS. So one is actually using a simple web application template or the web app builder configuration. So you can actually choose your own widgets, configure the services that power the widgets, and then you're good to go. The other one is App Studio. App Studio allows you to create your own native applications that can run on any smartphone devices. So you can actually develop it in a common programming language and deploy it across to iOS, Android, Windows, and so on. So the evidence that all these apps and app builders is really working is that just in the last year alone, the Esri users have deployed more than 500,000 of these apps, touching millions of people across the globe. At this juncture, I'd like to re-emphasize what Thomas mentioned about Esri's open vision. ArcGIS was built as an open platform because we believe in your innovation, and we realize that almost all of our users need technology that's reliable and that's able to move with you at a modern pace. So Esri's platform-independent approach ensures interoperability, be it via support for open standards, direct read for common non-Esri formats, or industrial collaborations. So ArcGIS encourages an environment for innovation where everybody can share their unique ideas with the community. You can use, modify, and customize any of Esri's open source projects for desktop, web, and mobile, and share it back or grow a new solution to share back with the rest of your community. The earlier 3D smart collaboration application that Thomas mentioned about, which between F4 and Esri, is a testimonial to it. So this is built actually on top of open source and a partner technology, but powered up with Esri's JavaScript analytic capabilities as well. Well, so that brings us to a close, and now is the time to act, to transform your organizations and embrace all these challenges and new technology in a way to envision what's possible. Smart GIS applications are already changing how we think and act, and it's about designing and creating and planning a more sustainable future and a much smarter world. With that, I'd like to end my presentation. Thank you.